Good morning, everyone. It's my pleasure to introduce our next speaker. Pam Maybrook is from Northeastern University, and she is a professor of chemistry and chemical biology there. She's also editor-in-chief of the Council on Undergraduate Research's flagship journal, Scholarship and Practice of Undergraduate Research. Pam teaches undergraduate analytical chemistry, and her current research interests are in science ed, and they include science writing, research ethics, the pedagogy of undergraduate research, and mentoring. So it's a pleasure to have you, Pam, and to see you again after all these years. Her topic today is peer review worth the effort? How does peer review inform students' written work?
Can you all hear me? Awesome.
Yes.
It's real. Thank you so much for that wonderful introduction, Kathy. It's really a pleasure to be here and to have an opportunity to share with you guys some of my work. I'm going to drop in the chat in case you haven't already got it. What I'm hoping is a direct link to the Google Doc, which corresponds to the slide deck. And I'll give you a second. Hopefully that works for everyone. And if it doesn't, go directly to the Google Drive to Wednesday and pick it up there, but I'm hoping that actually works. Got it. Did, yay, okay. You never know with these things. So this won't be in some sense, I'll call it an active learning session. What I'm going to do is share with you the results of an action study that I've been doing in my classroom, actually longer than a year, but I'm going to share with you the results from the spring semester of 2021. And I'm presenting it as a piece of action research to encourage you. Everyone here is teaching. Every semester you're teaching chemistry, so you're engaged in lab work, carrying out experiments. Your work in the classroom, it can also become a scholarship. And action research is a very valid form of pedagogy. You carry out work in your classroom, you evaluate it, assess it, you make a tweak to it, you repeat and refine the experiment, and you can share that work in scholarly journals like the Journal of Chemical Education. And so for that reason, I want to sort of present it in that framework. If you do have any questions about publication or about peer review, if you'd like to know more about some of my other work, I'm leaving my email address here, and I'm always interested in speaking with folks about what I do. So I'm gonna turn my little picture of me and you off. I want to open up by actually engaging you in a couple questions. And so the first question I have for you, and please feel free to unmic and to actually speak. Has anyone here served as a reviewer for a manuscript submitted to a publication? I hear yes. One yes.
Yes.
Okay. I think that was Mort.
Is that yes? Again, yes.
When I ask you that question, what's your emotional sort of gut response?
It's a responsibility of being part of the profession. I mean, you get sent a manuscript for review for a journal, and you have to provide the best response, the best insight to assist the editor as well as the author of the manuscript, because the information will go back to that person.
Ah, that's an awesome explanation of peer review process that most of our journals follow. What's your emotional gut response to being a reviewer?
You're asking me?
Yeah. Or
Oh,
Marissa?
oh, my gut response is, oh, shoot, I've got something else to do. And when does it have to be done? 3 weeks. Oh my God, I've got this, that, and so forth. But emotionally, I think it's gratifying. I'm happy that to be asked and to be recognized as some kind of expert at some level, and to get my opinion. It's very
Cool.
nice.
Yeah. Marissa, I noticed that you said you peer reviewed.
Yes,
What-
I have. Or I think chemical educator.
Okay. And what's your gut response?
Can you repeat the question? I was trying to deal with my 6-year-old daughter at the same time.
That's okay. How do you feel when you think about your experience as being a reviewer?
I enjoy it because I get to see what other people are doing, and how might that improve my submissions. I really kind of enjoy it, actually, when I have the time.
Cool. So we've got 2 positive responses. We have a sense of responsibility, a feeling of being valued in the community, a lot of positivity here. Has anyone been the recipient of feedback from your reviews?
Yeah.
Okay, it's probably going to be this, I guess, the same folks. So again, what's your gut response? How do you feel about that? Being the
Well, it depends on what the feedback is. When it is admirable and the reviewer thinks it's worthy of the Nobel Prize or something like that, then one feels very good. You go out and have a drink. You congratulate your research group for doing marvelous things, and you glow for a while. Of course, there's the other side of the coin. The other side of the coin is a comment that is can't, using words that probably can't be mentioned in any kind of polite company. I think the most difficult problem is having an insight as to who that reviewer is. Not the one that gives the glowing remarks, because that's wonderful, but the one that really lambasts the work, and perhaps in levels that are more critical than one would appreciate. And then to figure out, because it's a rather small community, I mean, if you're doing research in, it doesn't matter in what, the number of people who are possible reviewers who have the expertise is relatively limited. And if you go to enough meetings over a long enough period of time, you know all of the characters, and you go out and have a drink with them, and you chat and you talk and you communicate. But then when you know or have a pretty good idea of who that person is, I think that's the irritating part, even though it's peer review and it's without identification, which raises another issue as to whether peer review should be, whether one should know who the reviewer is, and whether that would make a difference in how nasty, shall we say, a reviewer might be.
So there's a lot there. I noticed
Yep.
that a number of you folks chimed in on the chat, and you said you remembered experiences from long ago. Do those feelings about peer review, are they still sticking with you?
So I guess there's 2 types of peer review. And when it's something that you're like, oh, I never thought of that, I should have addressed it, or I could make this clearer by by doing something else, is great. But the ones that are just like, this is a piece of garbage. Why did you submit it? Why did you even dare send something to our publication? Like, that's not helpful.
Yeah.
And
So
it does leave you with the feeling of like, well,
yeah. And the positive ones and the negative ones, they tend to stick with you for a very long time. So there's something inherently, I think we all feel valuable about peer review, but based on our own experiences, I think all of us can agree that peer review, if we're going to do it with our students, it sounds like we need to be thoughtful about how we engage in it, because there can be great positive benefits, but there may also be some negative challenges presented as well, emotionally, as well as developmentally. So what we're going to do is first, before I tell you about my work, I want to take a step back and look at what do we know about scholarly peer review? What do we know about peer review in higher education? And because we're all chemists, what do we know about peer review from the lens of chemical education? So first, in terms of scholarly peer review, it really is the peer of the realm, so to speak. That's how most scholarly publications are presented and put together. It's generally viewed as being critical to the global research enterprise. On the downside, reviewers are rarely trained. There are no formal standards. So what I bring to a peer review may be different than what Mort or Catherine or Leslie brings to her peer review. We bring our knowledge, we bring our experiences, and they're all quite varied. And that can be good, it can be bad. There's a lot of work now looking at different forms of peer review. We've already heard the term, I think double or about blinded peer review. Normal form of peer review is single blinded, where I know who I am, but my reviewer doesn't know who I am, and I'm reviewing their work. Double blinded is considered sort of a step up, where I don't know who I'm reviewing, and the person who I'm reviewing doesn't know who I am. And in the humanities and social sciences, they're moving to a different model, which is called open peer review. And that open peer review means that I, as a reviewer, my name is going to be associated with my peer review. And for some journals, that's done, and it's actually for a set fee, and my name would actually be published with it. And some folks, there's some work to suggest that when you are required to actually put your name to your work, that form of peer review may actually result in a better quality of feedback to the authors. There's also a lot of evidence that when you are the recipient of that bad peer review, the overly critical, maybe personally attacking form of peer review, that can have serious consequences, in particular for women and underrepresented minorities in STEM. And I'm giving you a lot of references that I do hope, if you're interested, you will mine and go back and look at. And I'm mentioning this about the negative impact because you can apply this to your students in your classes. If you're going to engage them in the peer review, then maybe we need to think about finding some way so we can ensure that the feedback our students receive is perhaps more constructive and not detrimental to their development as young scientists. Another big problem with peer review is that authors often discount. It's very easy for us to discount critical feedback. Sometimes the critical feedback is valid, sometimes it's not. But there's been recent work looking at what do authors of rejected manuscripts do. And most of the time when people, their manuscripts rejected, they take that work and then they just go to another journal. They don't use the critical feedback and attempt to inform their own work before trying to plant it somewhere else. So, it does say something about us inherently, in terms of how we approach critical feedback. And so we need to sort of factor that in and find ways, when we're thinking about our students, of helping them to be a little bit more metacognitive than perhaps we are sometimes in terms of receiving that critical feedback, being able to actually hear it and not just hear specific words and attempt to sort of solve minor problems, but to see the bigger picture in terms of what someone may be attempting to try to tell us in a kind and gentle way about our work. Does anybody have any questions about what I have shared with you so far?
Yes, I have a question, Sam. I mean, what role does the editor play in all of this? You're talking about the author, you're talking about the reviewer, but there's a middle person in there, or really there's an uber person, and that's the editor of the journal, who must make a decision as to whether to accept the manuscript or not. And I've, with many, many papers over the course of my career, I received at some point where the editor was critical of the reviewer and wrote to me, this is the review, but I don't think it's appropriate, and perhaps you want to think about something, but please submit a revised version. So I would go back and I would think about what was done, and I would accept it or not and revise to whatever extent I wished to do, and then resubmit it. And sometimes it went to another reviewer. Very often there would be used 3 reviewers. This is fairly common in a journal, not to overload any particular group of individuals, but 3, so you have an odd number and you sort of look, well, 2 yes and 1 no sort of passes muster. So I think, to me, all along the chain, the author, the editor, the reviewer must be intellectually honest. That's absolutely critical. I mean, we're dealing with science, we're dealing with knowledge, and we must be totally critical and try as best we can to divorce ourselves away from the emotional connection that we have to our purple prose, shall we say.
Yeah, you've pointed out the role of the editor, I think I'll say, is sort of somewhat analogous in the classroom to us as the faculty member if we're going to oversee the peer review. Sadly, there hasn't been as much, I'll say, scholarly work done to date, sort of looking at the impact of the editor in the publication chain. Another problem associated with it is that it's quite variable, the different transit, or I should say the stages through which and different people that will actually handle and evaluate the manuscript at different points in time. Some journals, the editor-in-chief will actually be the first person who takes a look at it, sees if the manuscript fits the mission and the scope of the journal, and provide immediate feedback. Sometimes there will be actually a corporate entity, a company that will sort of look at it and perform that first step, that first call. It may go directly to a professional associate editor, someone like at Nature, who's working full-time and acting as an evaluator. Other times it might go to someone like Mort or me, who's a faculty member who is in their, I'll say, spare time, serve or limited extracurricular time, serving the community in attempting to value and help to hold up good scholarly practice. And that person will choose the reviewers, and then read those reviews. Sometimes when the manuscript comes back, the editor will, as Mort pointed out, share all of the feedback with the author and share their particular point of view. Some journals don't provide any feedback, and they will simply send it back and say, thank you, but we have no space in our journal. At the current time, we receive many manuscripts, in which case you get no useful feedback at all.
That's terrible.
Yeah, and other journals from the inside, they'll pick and choose. They may say that your manuscript's not publishable, but they'll pick like one reviewer, but they won't share the other two reviews that came back that may have been positive. So you don't necessarily have sort of a holistic picture. But one of the biggest problems is, I will say right now, there is limited information in a forward-facing way for the community on what this transit process looks like. Transparency is a big issue. The Royal Society of Chemistry has made an initiative which 39 signatory publishers and professional societies have signed on to, based on an effort in diversity, equity, inclusion, and respect. That's the basis for it, in order to begin to make this process more transparent and fair for everyone. I think I got a little bit off track, but I think I did sort of address your fundamental question, right? Okay. All right. Anyone else before I go on? All right, so there are a number of common problems. What's really nice is there are actually several articles that sort of lay out the common problems in manuscripts. This is for the biomedical sciences, but I think it's fairly representative across the board. And the common problems are people don't do the background work you really need to do before you start to do the research. They may not choose an appropriate methodology. There has been a widely stated problem. Open science in the field of psychology brought this out in terms of how big N is. You need to have enough data for the data to be meaningful and then to be generalizable. You need to think about what your sample looks like. Is it representative of the population that you're looking at? Did you describe your methodology enough? Is it a solid methodology in terms of producing the results that you're going to claim? Presenting enough data so that your reviewers can be convinced that your arguments are sound, performing the appropriate statistical analysis if it is a numbers-based study, and then overreaching, over-interpreting your data, and then writing and proofing are some common fundamental problems. So I have one more question for you, and that is, we've talked about general sort of science experiences. Now I'd kind of like to know, have you used peer review in your classroom, and what has your experience looked like? Has it been a positive one, negative one? Have your students learned?
Pam, how would you define peer review when it comes to a classroom? I mean, I can think back, although it's now many decades, think back of my experience in the classroom. There were many ideas, many procedures that were used for students to interact with each other, to collaborate, and so forth and so on, maybe even to evaluate ideas that came back and forth. But I never thought about it as peer review, so I would appreciate a definition or something to focus on exactly what it would be.
Okay, it's a very fair question. I'm going to share with you from chemical education, sort of the variety of characteristics that have been put forward in manuscripts as being peer review. but basically having the students in the class evaluate their classmates' work. And it's usually written work that we're talking about. And in terms of what specific assignments, again, that's what I'll share, but it could be lab reports. It could be writing up work from a course-based undergraduate research experience, a whole lab or something, a project like that. It could be doing literature work and then writing up a paper on a specific topic. But those are some examples. Has anyone here engaged in peer review in your classes?
I do it in limited ways, but what I've found over the past few years is that before you even get to that, I need to teach my students how to productively talk to one another. There's a whole thing that started in Southern Maine in a group called Turk, and then got picked up by the Research and Science Education group at University of Maine on what we call productive science talk. It's similar to some of the stuff that goes on at Next Gen and so forth. And I found that getting students to understand, how do you question one another's ideas? How do you elicit more information? How do you talk about ideas and not people, all that kind of stuff. If I do that first, then I can ask them, and usually I do it in terms of drafts. Before somebody's handing something in, it could be, whatever kind of work they're doing, I will give them a form in which they can review one another's work and give them help before they turn something in to me. So that I have done work with that in small ways. It's not big pieces of work, it's small pieces of work. I work at the high school level.
And I don't think there is such a thing as a small piece of work. I think it all matters.
Yeah.
Sorry.
I've done it as well. I've done it in two different methods. One would be through lab reports. So kind of what Chris was talking about as well. And I see a couple other people in the chat as well talking about lab reports. I normally have them do just a random lab report all together. We go over like parts of the lab report and kind of reviewing it. And then I do where the students blindly look at other students' lab reports for the first time before turning it in. And then the other time I use it, which I find is much more valuable. I mean, the lab reports help, but they can look at random lab reports, and I think that's enough for them. For mine, at least, they don't seem to get a lot out of the peer review for lab reports because we all did the same lab. So it's a lot of the same data, a lot of the same wording. But I find that my students value the value in having my students review when we do an inquiry lab where the kids have to actually come up with the method, much more like real world application. I find my students do a lot better at analyzing and peer reviewing that because they didn't do the same lab. So they're now looking at, can they actually repeat this lab with what the students gave them? And so it's much more interactive, and the feedback is a lot better because it's not nitpicking like wording. It's now nitpicking and looking at the whole picture. And can I actually take this and apply it to the lab myself? So the lab reports are valuable, but I find doing it with the inquiry before they turn in their big write-ups on Inquiry Lab are really valuable in my class.
Cool. And Chris, I noticed you posted something. Would you like to say something about it? Your peer edit mode of writing?
Well, I mentioned that the College Board and the AP Chem lab manual has 3 sample lab reports that I do with my AP kids, and I find it really useful as a way at the beginning of the year to get them thinking about lab reports. But my old district had a really great rating program where like every kid in every class writing across the curriculum was trained in peer editing. But the thing that made it good was you would literally only give them 3 things to focus on. You'd say, okay, did the writing get the point across concisely? Did it explain the scientific theory behind it? And was their grammar good? Like you give them 3 different things to focus on, and it just helps, like not to focus on everything, to give them just targeted things to focus on.
Cool. Yeah, I agree. All right, I think we've heard some good ideas here. And so now let's take a look at higher ed and look at the picture. I think most folks feel that peer review has demonstrated effect. It really benefits students who are low performing. It benefits women and minorities, but it has a very strong polarizing effect, especially in the case of women and minorities. If they're the recipients of poor peer reviews, and this goes back to Sue's earlier comment about, I'll call it calibrating, or getting students to understand how to express themselves properly. If they get the wrong feedback, it can have a serious detrimental effect. And then if you sort of think back to what I told you about us, for peer review, that's a well-known effect there too. So it's clearly across the board. It works better based on the higher ed literature, and this is across disciplines, when you provide the students with training and when you provide them with a feedback form. And the term feedback form can be a rubric. It doesn't necessarily have to be. So that's the broad picture. Now we'll look at, well, when we're talking about peer review, what are most folks doing in terms of chemistry? So it's been most commonly used in writing lab reports. It can even be small pieces of a lab report. There are examples in general chemistry where you might have the students write an introduction for one lab, a method section for another lab, and they sort of scaffold this each piece across the semester, and then it culminates in writing a full lab report. It's literally anywhere in the curriculum from general chemistry all the way up to physical chemistry, and a lot of work in high school level in terms of AP in particular. At the university level, there are some schools that offer standalone chemistry writing courses, but I have to say that's I think an unusual situation where you have a department that's willing and able to have a faculty member teach students a full semester writing course in the curriculum. And where you most often seem to see it at the university level is in the organic class. And it's often embedded either in the lecture and giving students a molecule seems to be sort of a chemical compound, a common approach, or in lab experiments, as I first mentioned. The peer review is typically done with smaller classes. I think that kind of makes sense. It's sort of hard to police peer review if you're working with large groups of students. You don't usually see, except one single instructor participating with these small groups of students. And I've seen it in the papers anywhere where students are receiving one peer review to typically a maximum of 3 peer reviews. And so here I'm going to step back to the higher ed literature and point out, according to the higher ed literature, if you really want students to get the benefit of peer review, you're supposed to provide them on average 5 peer reviews, which can be very difficult on your students as well as on you. And most folks, when they're engaging in peer review, are providing their students with a rubric. And I want to make sure everybody, when I say rubric, sort of has the same picture in mind here. So I'm going to sort of pop over to another screen so I can sort of share with you what a rubric looks like. And so the rubric can be something like, this happens to be nomenclature and bonding, but it could be like notations, solution accuracy, logic and reasoning. I picked this to show you that it doesn't necessarily have to be writing, and you can do peer review for other activities and concepts in chemistry other than writing. This is an example from a program dedicated for use for peer review called Critic. which I'm testing out this semester. Scott Johnson at Brigham Young University in Idaho has been using this in his chemistry class. And most rubrics, when you use them, appear a little bit more, I'll say, full. You have different levels. You can give them different names. Here he's called level 4 is advanced, proficient goes all the way down to not so good, novice. And for each of the characteristics, you can value it point-wise. There's a description, and often you will allow the students, even if you have this rubric, not just to select a number, but to actually provide the student recipient of the feedback with actual written evaluations. So that's what I'm talking about when I'm giving you example of what a rubric is and what most people talk about. But I've given you a bibliography. I hope that that's there for some of the peer-reviewed work on peer review in chemical education. And so you can take a look at some of those manuscripts if you want to see examples of rubrics that those folks used in their work. But they're often, as I said, lab reports, papers. They can be one section of a paper at a time. Some folks are leveraging software. I've already mentioned Critic. Another commonly used program is a CPR, which was actually created by a chemist, organic chemist at UCLA, and is a way to sort of provide that first step of helping students to understand how to express themselves and how to recognize what quality is, what good, better, and best is. And if you're interested in learning more about calibrated peer review, I've also provided you a link to a bibliography about CPR, or calibrated peer review. I've seen in chemical education, this is done anywhere from having an individual class where you're doing it. It can be collaborative, one team involved a chemistry class and an English class. And so the chemistry students wrote, and the English students evaluated or performed the peer review. And then the chemistry students provided feedback on that peer review to the English students. It can be team-based, so you can have a team of students where they're swapping roles. And so one student is writing, another student is evaluating, and another student is performing that editor function in terms of sort of valuing and evaluating the reviewer's work and making a decision about it. So there's all different ways that you can perform peer review, or that peer review's been done in chemistry. All of this said, there's actually been very little objective work. And so if you look at all of those wonderful papers, they're largely based on providing little anecdotal student comments and student perceptions. So it's not really objective work. And I think we all value effective objective work. Some of the common challenges, students find it hard to accept criticism from peers. I'm going to say, I feel the same way. I find it hard, even at my well-advanced age, to accept criticism from peers. It's easier to accept comments that are positive and affirming. Anonymity, they struggle with as young people. The CPR, which has been used quite a bit, for most folks, they discover there's a significant time investment on that initial effort to calibrate students on the peer review. And most folks who've engaged in peer review in the classroom have found when they do it, of course, just like us, students only revise if they're provided with very specific feedback. So if they're given questions, open-ended questions as feedback, it's hard for them to sort of process and to make sense out of that. And also if the comments are very broad and encompassing. And so this is, I would say, advice that we can all use if we're going to do peer review. Encourage our students who are performing peer review to give very specific feedback. So now I'm going to sort of take you very quickly through what I have done in my classroom. I teach an undergraduate analytical chemistry course. The students in my class are anywhere from sophomores to seniors. The sophomores may have taken AP English and exempted out of our freshman English course. The seniors may have had 2 or even 3 writing experiences. So one we call writing in the disciplines, but that doesn't necessarily mean they can write. And my course is what's called a writing intensive course in our curriculum, which means that students are supposed to be doing a discipline-specific writing work that's meaningful in terms of the discipline, and they're supposed to be spending a certain number of hours on it. I typically teach anywhere from 20 to 40 students in analytical. This past spring, I had a nice number, it was 28. We carried out all of our work, unfortunately, virtually. I love working with my students in person, and that was quite a challenge for us. This past year, we transitioned to Canvas from Blackboard, and that was an added challenge in terms of trying to figure out how to use Canvas to perform peer review in the way that I do it with my students. I value our writing work significantly in the course. It's worth 1/5 of the total value. And my students aren't just chemistry majors, they come from a variety of majors that I've listed here. So what am I after, and what is the writing project? So I'm after a number of things. I want my students to actually engage in writing, scientific writing in the form of a technical paper, something like a mini review or a tutorial that you might find in an RSC publication. I want them to do a form of writing, write about something that they value, that they feel that they are going to get something out of. And that feeling of ownership, that agency, I find usually has a significant impact on their work. I do want it to be content focused, so it's going to be analytical. And in my case, it's going to be introducing them to a specific technique that I can't otherwise teach them at the university. And I'm basically trying to teach them how to fish. I'm teaching them how to engage in research by introducing them to Web of Science, teaching them how to read a research paper, and then engaging them in the process of actually using those tools to teach themselves about this particular technique. And I'm providing them with formalized standards in the form of rubrics. And the rubrics that we'll use for our peer review will be the same rubrics that I will use in evaluating their final formal work. So our project scaffolded. First, they do a lit search with Web of Science. They then prepare a bibliography using the ACS style. We have a software program called EndNote. Some of my students use Mendeley. There's a variety of different sort of reference management software programs. And some of my students use no reference management software, kind of like going back to my day, pre-computer. And that's fine. And I help and work with all of them. But they start out after they have their bibliography by writing a fundamentals paper where they're teaching their peers about how their technique works and explaining to their peers about the ins and outs of that technique, what makes it good, where it can be used. We call those figures of merit in analytical chem. And once they understand their technique, they pick one application paper that they've identified in their bibliography on some subject that interests them. It could be medicine, it could be forensics, it could be materials, but that analytical paper is focused on some study, and it uses that in that study, that analytical technique in a specific way that's meaningful. And once they've done that, my students coalesce into teams and they prepare a final team poster that is in lieu of our final exam. So what does that look like? I initially identify a list of techniques. My students identify a set of peers they would like to nominally work with. That's called loosely the team at the beginning. They select a technique and they individually write a fundamentals paper, here depicted as paper 1, and the application paper, which would be paper 2. Now that they've written those papers, every student has independent knowledge of the technique because they've all written paper 1. They also have identified some paper of interest to them. That means that together a team of 4 students has read 4 papers about that specific technique. And they talk about it among themselves and they identify one application from the 4. Sometimes my students will actually say they don't like any of those papers and identify a completely brand new one, and that's fine too. And that becomes the basis for a poster that they're going to use to teach their peers through the presentation of that application study to the rest of the class. And at each stage, my students are engaged in the activity of peer review. So this is from an assignment standpoint, what the semester looks like. They first do a draft bibliography. I have them do 2 peer reviews there. They get the peer feedback, they submit the final bibliography to me, I evaluate it with the same rubric they used in the draft. They then go on, do a draft fundamentals paper. Because they are young scientists, it's really challenging for them to evaluate multiple papers. So up to this point, I have had them evaluate 1 peer's work. But we'll talk about why that's going to change. So it's 1 peer review from this stage forward. They use the same rubric, use the feedback, submit the fundamentals paper, rinse and repeat with the application. Okay, so that's what that looks like. And here are the topics. They're all really sexy, cool topics that students are reading about. With COVID, I tried to find things everyone was interested in learning, something related to COVID. So cryo-electron microscopy for my more medically interested students, surface plasma and resonance for the same reasons. These are sort of like alphabet soup, but the whole idea is these are things I can't offer my students in the analytical lab, and they're potentially interesting to them. Sears, surface enhanced Raman, is an often common technique in forensics, and it didn't get chosen this last semester, but it's an often favorite. So peer review, I have engaged using Canvas for the past year. For my part, all I'm going to say is very kludgy. You can set up the initial peer review, but Canvas does not provide a mechanism for you to then provide valuations to each of the peers. And that's the downside. And so I tried to do this as an individual. It's a heck of a lot of work trying to sort of connect the dots between that, the students' peer reviews, and then a separate assignment where you're providing the peer feedback. So that's a downside of the Canvas learning management system. I already talked about the rubrics, and I gave you the numbers for the peer reviews. So I actually have objective data, and this is where I have been looking, is at the objective data. I have all of my students' numerical evaluations for the peer reviews that they performed. I have their final grades for each of the different peer review assignments. I also have the comments for the students' peer reviews and the comments I gave my students for the final papers that they submitted. So I can actually objectively look at whether the students improved in a specific area related to the rubric, whether they didn't make changes, what kinds of changes they made. Did students make local changes based on specific feedback, or did they see the bigger picture when their peers provided them with critical feedback? For example, maybe a student said that the ACS style seem to be missing acronyms for journal names. Did my students look more holistically and more critically at the format for all of the references? That would be nice. Or did they only look and check and fix issues related to the journal acronym? Because they might have missed continuous pagination or some other issues. And I can see whether they improved or whether they stayed the same. I have also engaged in focus groups with my students. So I have at this point from the spring semester identified 8 students. 5 of them agreed to participate, and I have conducted qualitative evaluations of that work. So this is an example of the kind of feedback that I have. I'm not expecting you to be able to really see too much of anything here, except this is the rubric for a specific assignment. These are the numerical evaluations. Those are the categories. These are the student comments. Student submits the final assignment. These are my evaluations over here. So again, I have the comments that I can compare. I have the student scores. And then I can see whether the student actually made changes. Did they respond holistically? Did they just respond to the minutia? Did they improve? Or maybe things stayed the same. And remember, they have multiple assignments. So I can look holistically from, for example, paper 1 to paper 2 now. And I can see in specific categories, and the categories are preserved for the writing assignments. How did they improve, or did they remain the same? And in what areas did they improve? And so this is for the class. This is showing the students' final course grades to give you a sense. I can map against those as well. In green means the student improved overall in that particular category. The white is not bad. The white is actually good. It means the student did great the first time, and they remained great in that area across the course of the semester. And red is not so good. It means that they never really got it. They remained the same or got worse in that specific category. And so I think you can see there are certain areas that are more green than others. There are certain areas that are more red. So we'll look at the individual assignments really quickly. I have the rubrics on the right-hand side, and we'll talk about what the students did, and then I'll pull everything together. So objectively, the students did a good job as peer reviewers. They get a lot of information at the outset on how to express themselves. They read the Peer J article this last spring, so they know the impact that peer review can have in a positive or a negative way going into this. And so that isn't an issue for me, but students do benefit from the peer reviews. They listen to their peers, they resolve many of them. They tended to resolve more issues on the bibliography because that's more objective when you're talking about issues like time frame for the bibliography, what time it covers, quality of sources, whether the format is correct, and whether the work looks overall well presented or not. So students do a good job there. But there are some students who they see the minutia and they miss that bigger picture. And that specifically relates to the reference format as a problem. And so for this, one thing I will be doing moving forward is providing a more detailed checklist to sort of help my students in this area. So let's talk about the writing because that's more interesting. So paper 1's the fundamentals. You have the characteristics on the right and the objective lessons on the left. And again, the critical thing here is that students do resolve many of the issues, but there's actually 40% roughly who don't look under the hood. If they don't see the exact specific words describing what that problem is, they don't look in a more holistic way. So if they have problems if a peer says to them, I couldn't find the topic sentence, or I couldn't figure out what your paper's about, they don't look more critically at their work. They don't look at the introduction section and see whether it's focused, what, how it is addressing the topic, or whether it's not. And there's just a small stubborn portion that, just like us in terms of peer review, people do point out to them the errors. They are specific. They are global or small, but the students just don't respond to the feedback. They ignore those. So there's that small issue. Overall, where students continuously seem to struggle, it's writing overall. Topic sentences, being able to recognize what's an argument, what is evidence, crafting paragraphs that put this information all together in a coherent way. So quality of writing is a struggle. Unfortunately, even for many of my students, grammar, spelling is a continual challenge, even with Grammarly and a lot of the tools, but writing is a big problem. And then I call it the minutia, but the references and the citation markers, which in today's day, with all of the resources we have, you think would be a given. And then where I really want them to address is, of course, the analytical. And so some of the students struggle on that, and that's okay from my vantage point. But the struggle is for the peers and for the authors in being able to identify problems with the writing, and then even if they receive it, in being able to hear that feedback and make substantive changes. And so paper 2 is pretty much the same story. There's really no new story here. It's the same fundamental issues. It's the writing, it's the introduction section in particular, some issues with the conclusion section, but most students resolve that. But it's the quality of the writing overall. So does peer review inform students' science writing? For some it does, yes. I did see strong evidence that for my students, they all managed to, in the end, be able to put together by the end of the semester coherent conclusion section, which is often, a very tiny paragraph. They were able to organize their thoughts sufficiently so there really was a structure to their work, and they were able to put forward a professional presence. But they overall struggled with writing, and it's this issue of topic sentences, understanding what an argument is, what evidence is, and how to put that all together. So unresolved issues, this is sort of a summary of pretty much what I've said over there, said before. In the idea of inductive versus deductive, my students also struggle with, but those are the critical issues. Students struggle with figures and tables. This is more, I'll call it structural issues, identifying the figure or table in the actual text of the paper, providing copyright, getting confused between what's a figure and what's a table. One would think wouldn't be an issue, but it's a significant issue at the university level. So that might sound rather negative. I realize it's actually not. My students did learn a lot. They felt that they learned that it was important to understand before you start writing. And I think that is really huge if you can get students to understand that. And that if you do understand something, that leads you to finding the right words. They come away with a feeling that they understand that science writing isn't about hyperbole. It's about factual and unpretentious writing. And those are, I think, big yays. They all benefit from peer review, and they showed that benefit in their evaluations for the course for peer review, but also through the focus group. They really like and they value highly what they hear from their peers. They felt that the feedback was helpful. It helps them to identify areas of improvement. And importantly, they see that when they're engaged in peer review, they're having the benefit of being able to see other people's work, which provides them with models and examples that gets them to rethink how they might present their own work. And again, those I think are some big yays. Lessons that I learned, which I kind of knew going into it, but one peer review, no matter what you do, there's nothing you're going to be able to do to fix that. You have to engage in 3. And the focus groups are very helpful because they showed me that my students really are, even though I was hesitant to ask them to do it, they're more than willing to review 3 papers because they really do see the benefits. At the same time, I say they valued their peers' work. Sometimes they didn't evaluate their peers' work. And this was the weaker students who really viewed their peers as being like them and saw them as being inexperienced and lacking the knowledge to provide them with substantive reviews. And so that's an area that I think deserves some additional attention, and I'm still contemplating how I'm going to address it. But this was specifically with the lower group of students in my class. And the question is how to get them to see that their peers may be capable of giving them better feedback than they think. Students do struggle with fear they won't meet their peers' expectations in terms of doing their peer reviews, and they really did not like Canvas as a format. It's really hard for them to put all the pieces together when they have to look in different places on Canvas. And so that's where ultimately Critic will come in. It's a tool I'm going to move to. But I've provided here some of the assessment data. I won't belabor it. I'll let you guys look through it. But you will see that the students really did value the peer review. They felt they got a lot out of it. I use SOLG, which it has evidence of validity as an evaluation tool, but it looks at student perceptions. And I shared with you some of the student comments. Of course, I always say that sort of self-congratulatory when you pull those types of comments out about your own work. But the students really did value this particular assignment as much work as it was, and they did acknowledge that. And so peer review really is worth the effort. Our students really do learn from peer review, but it's really important for us to scaffold it properly. It takes time and effort. We need to show them that the time and the effort are worth that investment. And we need to find a way to help our students, that sort of that metacognitive piece, to be able to see that bigger picture. And I say that and I point us back to our own selves, because that's a struggle for us as researchers and academicians, as scientists, to listen to and to see that bigger picture in all of the feedback that we get in our own lives. Guiding principles, it's really important to start with a calibration activity if you're going to do this. I do that. I'm happy to share what I do in my classroom. It's really important to use rubrics, and it's that rinse and repeat. It's really important. My students said they really valued that we had 3 assignments over the course of the semester and 3 opportunities to get feedback. That really was critical to them in making improvements. And so with that, I'm going to stop here, and I think I'm a bit over, and answer any questions that anyone may have. And thank you.